This video is a preview for our class on partial fraction decomposition. In a previous math class, you might have been asked to add two fractions that look like this. You would do so by first seeking a least common denominator, and then simplifying the expressions. So here we're going to simplify the numerator after we got a least common denominator. Finally, now that we've simplified the numerators and the denominators are the same, we can combine this to a single fraction. And we would get that our original two fractions that were being added together, when fully simplified, becomes x plus 6 divided by x minus 2 times x plus 2. This is a procedure that we've done many times in previous classes, and in partial fraction decomposition, it's interesting that we're actually going to do this procedure in reverse. In partial fraction decomposition, we're going to begin with an expression like this. And notice this expression is a fraction where the denominator can be written in a factored form. And we're going to ask ourselves, what in this case two fractions must be added together so that the result is this fraction? Retracing our steps, we see that indeed we would actually have to have 2 divided by x minus 2 plus negative 1 divided by x plus 2 to simplify to get this expression. One thing we might want to note here is that we have an x minus 2 in our original expression in the denominator, and we have x minus 2 in the original expression, or in the this equivalent expression. X plus 2, x plus 2. The process by which we go from this original expression to this is called partial fraction decomposition. Let's go through this example. Suppose we were given this and we were asked to simplify it and find what two fractions would added together would give us this expression. In order to get x minus 2 times x plus 2 in the denominator, one of the fractions had to have an x minus 2 that you would then add to the other fraction, which would have to have an x plus 2. For now, all the information that we know is that the two denominators must look like this, but we're not yet quite sure what would have to be the numerators so that whenever this side combines to be a single fraction, the numerator of the resulting fraction would be x plus 6. In order to combine these to a single fraction, we would have to find a least common denominator, which we could do by this method. Notice whatever goes here is going to be multiplied by an x plus 2. This gives us some intuition on what would actually have to be here. For instance, if it was an x, notice that would generate an x squared term, and we don't see an x squared term here. So instead, we can be pretty confident that this would actually have to be a constant. Let's call this constant a. Similarly, whatever is here would have to be multiplied by x, and then multiplied by negative 2, and then whenever everything's added together, it would have to result in an x plus 6. So this numerator is also some constant. For now, let's just call that b. We would next get this. The right side can be simplified to a single fraction. Since the left side denominator is the same as the right side denominator, then the only way these two fractions can actually be equal is if their numerators are also equal. So this allows us to write a different equality, that x plus 6 must actually be equal to ax plus 2 plus bx minus 2. At this point, I'm going to distribute the a, distribute the b as I rewrite it, so ax plus 2a plus bx minus 2. Grouping like terms, we get ax plus bx. Oh, and this was supposed to be a 2b. So plus 2a minus 2b was supposed to equal x plus 6. We can then solve for the value of a and b that would make this true. There's an x common to both these terms, so we can factor out an x and we would get a plus b times x plus 2a minus 2b. When we introduced a and b, we knew that they had to be numerical values. So we can equate the related ideas. Okay. 6 is a number, and we know 2a minus 2b must also be a number. A plus b is the coefficient in front of the x, and we see there's an implied 1 in front of this x. This would set us up to two systems of equations. A plus b must be equal to 1, and then 2a minus 2b must be equal to 6. If we can solve this system of linear equations, then we would know exactly from the beginning what over x minus 2 plus what over x plus 2 would give us this overall simplified fraction. To solve the systems of equations, I might just solve for one of the variables and then substitute into the other expression. So we solve for a and we substitute in this value into the other equation. Solving for b, we could subtract 2 from both sides. Negative 4b equals 4. This would imply that b has to be negative 1. If b is negative 1, then we know that a plus negative 1 equals 1. This tells us that a would have to have the value of 2. Let's bring this back to the original problem. Looking back at the original problem, we now know that 2 divided by x minus 2 plus negative 1 divided by x plus 2 could simplify when we add these fractions together by first seeking a least common denominator to x plus 6 divided by x minus 2 times x plus 2. So as our first example of partial fraction decomposition. We'll look over more examples in our next class period.